Hi and Assalamualaikum. My name is Nur Nabiha Arishabella binti Abdul Razif. My matric number is S62831. Today I will presenting about ocean iron fertilizations. So the first part is history of iron hypothesis. So what is iron fertilizations? Iron fertilization is a method in decreasing carbon dioxide level in atmosphere by nutrient supply to boost phytoplankton growth and also promoting marine carbon sequestration through the biological pump. So how did they know about the atmosphere gas composition in ancient time? Number one, during the last glacial maximum, trapped air bubbles in Antarctic ice core containing atmosphere's carbon dioxide. Number two, atmosphere's carbon dioxide in last glacial maximum much lower than pre-industrial times. And last but not least, last glacial maximum is 180 ppm compared pre-industrial time, which is 280 ppm. So how did Martins come to his finding? First of all, 3 lab workers were deployed on a research trip to the Antarctic Ocean in 1989 to conduct a small-scale experiment. So, as a result, plastic bottles were filled with phytoplankton and salt water. Some bottles had iron added, while others had nothing added. As a consequence, phytoplankton clouded in the iron-enriched saltwater bottles after 6 days, but phytoplankton without iron remained unchanged. So, Martin presented the following iron hypotheses. First, increase in atmospheric carbon dioxide gas. Second, iron fertilization proposal. And third, undergoes biological pump. So, from my study, I came out with 2 objectives of this experiment, which is first, to purposely fertilize NNLC with iron in order to boost the strength of the biological pump, and second, to improve oceanic carbon dioxide removal from the atmosphere. A specific area of iron fertilization in the world oceans. From the article I have read, there's 3 specific areas, which is first, subarctic North Pacific, second, equatorial Pacific Ocean, and last, southern oceans. So why are these being of interest by scientists and industries? First, the areas are high nutrients and low chlorophyll HNLC regions. And second, due to a shortage of iron, phytoplankton cannot fully use the available micronutrients for photosynthesis. And third, primary production in this region is relatively low, despite the high availability of micronutrients in particular nitrates and phosphate. So, iron-climate relationship. So, according to hypothesis 1, iron X1, ocean iron fertilization could enhance phytoplankton production by relieving iron restoration on phytoplankton in HNLC regions. Thus, it will absorb a massive quantity of carbon from the atmosphere. Since this experiment was conducted from 1992 until 2011, so how many experiments have been performed so far to study ocean iron fertilization in this field? So there is 2 types of iron fertilization, which is first, natural ocean iron fertilization, second, artificial ocean iron fertilization. So for natural, they have 6 experiments, which is 1 at the equatorial Pacific, 5 at the southern oceans. While for artificial ocean iron fertilization, there has 13 experiments, which is 2 experiments at equatorial Pacific, 7 experiments at southern oceans, and 3 experiments at subarctic North Pacific. While for LNLC region, there is 1 experiment was conducted at subtropical North Atlantic. Limitation in these experiments, which at the equatorial Pacific, this is insufficient experiment durations. Second, micro and micronutrient limitations. And third is subduction if fertilized batch. While at the Southern Oceans, first, the experiments were slight limitations. Second, insufficient experiments durations. Third, were high deletion rate by small batch size. While at the subarctic North Pacific, the limitation is single ion additions. Second is insufficient experience durations. For these experiments, it will success or not. So from my understanding from the article, not every experiment may be just a success. So this is because every experiment has its own limitation on how it can be conducted. For example, iron X1, the first artificial ocean iron fertilization experiment, found that the dissolved iron content in the fertilized patch rapidly declined from 3.6 to 0.25 nm 4 days after iron additions, indicating a limit to the amount required for phytoplankton growth. And last but not least, the next is improvement that can be made for the future, such as the scientists can improve where they want to perform their experiments, the time to perform the experiments, such as they need to choose the best time, the best seasons, so that they can get the best result for the experiments, and also the duration for how long they want to carry out the experiment. And they also need to improve the effective tracing and the strategy on how they are going to carry out the experiments. And last but not least, monitoring of possible effect also need to be focused on when carry out these experiments. So that's all from me. Thank you.